we are going to be looking at parameter estimation with R. So, parameter estimation. Now, we have been building models, and we have talked about the need to bring in data, because every model you have built, when you have not calibrated the model, it still remains a general model that is speaking to nowhere. And even though you can run some simulations, it's just a general thing you are looking at. But most of the time, we want to be specific. We want to look at a certain data to calibrate our model. And for that, we need to estimate some parameters. We need to fit the model to data. And so the essence of parameter estimation is, for definition, we say, is a process of using data to determine the values of parameters in a mathematical or statistical model. And it involves finding numerical values for parameters that best fit the observed data. All right, some of us have been given some kind of data and that we have to work with. Our parameter estimation answers the question, what value of the model parameter makes the model output match the real world data as closely as possible. Now, it is crucial for fitting models to observe data and thereby assessing the ability of the model to adapt to real life. A model that fits well to data can be very resourceful for quantitative analysis, like we have been saying, and such as scenario analysis, sensitivity analysis, uncertainty analysis. So we looked at sensitivity analysis yesterday. And then if you have a model that performs well post-calibration interval, such models can be used for prediction. Yes. Different methods are available for us to do parameter estimation. We have what we call the least squares method, which tries to minimize the differences between the model prediction and the observed data. We will see as we go on. And then maximum likelihood estimation as well, which finds parameter values that maximize the likelihood of observing our data. Maximize the likelihood of observing our data. And then we also have Bayesian inference, which combines prior beliefs with observed data and using probability distributions. So generally, when we have we need to fit or estimate parameters. Number one thing is that you have your model, you have your data as well. Now, model and data seem to be sitting separately, right? We have to link them. Now, for the kind of model that we are doing, a mathematical model, now at this point, let me quickly explain, because I will be looking at both ends. Prof explained to us that statistical models are functional models, right? What is the intention of functional models? Functional models are just interested in capturing the pattern that you observe in data. For instance, trying to find the relation, what's the function that builds the relationship between some input variables and output variables. Is that okay? So you have X as the input, you have Y as the output. So that kind of function just wants to see how does these two interact. For instance, you have a data on weight and height. Weight on the first column, then height on the second column, right? And you plot weight against height. And you see the way the curve is looking like. You are interested in looking for a function that will be able to explain that relationship. That curve, that will be able to follow that curve as well. That's statistical model, that's a functional model. It's not looking at the internal dynamics of that data. For instance, mathematical model will be interested in, okay, when we give, for instance, some of us have been giving cases data of malaria, right? So mathematical model, and it was observed over time, isn't it? Now, if it was functional model will be looking at how can I get something, a function of time, because you have time and cases, isn't it? How can I get a function of time, where x will be on the x-axis that we have time, and on the y-axis that we have what? Cases. Such function that can capture the behavior that you see in the data. That's what statistical model will do, functional model. Do you understand? But statistical mathematical model won't do that. You have cases in your hand. It's thinking cases of what? Cases of malaria, isn't it? So and then he begins to think of what are the processes that bring about malaria cases, right? Somebody must be bitten by an infectious mosquito, right? Must have undergone latent period, become either symptomatic infectious or asymptomatic infectious. Do you understand that kind of thing? It's bringing in the involvement of different factors that interplay to determine the current state of the system. Is that okay? So that's what mathematical model is doing. So why statistical is looking at that function, it's not concerned about the interplay of the factors that determine the state of the system. That's why for mathematical modeling, you'll be talking about state variables and parameters, because we need to know the state of the system, right? But for functional model, we are not interested in that. We are just interested in a function that tells us the relationship between the input and the output variables based on the observed pattern in data that you have. Is that okay? All right. So for that, for mathematical models, for instance, when you have a process-based model like that, system of differential equations, you must necessarily know what data do I have in my hand, which part of the data correspond, or which part of the model corresponds to this data that I have in my hand, and we are going to see it as we go on. So necessarily there must be a linking function. Are we together? Which you call the estimator. Is that okay? So when we have been able to bring the model and the data together, then we define an optimization algorithm that tries to help us find the parameter value that best suits the data, such that the model, fits the data closely. Is that okay? All right. So now we'll start with the model. Now, like I've just explained, that though parameters in any kind of model can be estimated, however, in this course, we give attention to equation of course, which is the functional model that I first talked about. You also realize that Mr. Sam, when he was teaching us, was talking about some thermal responses, right? Are we together? Yeah. To some climate variables, isn't it? Looking at some of the behaviors, either biting rate and co, and then we're trying to bring up equations that express that in terms of temperature. And you remember that you have to fit the curve, quadratic curve. And I remember some of you were asking questions. How did you get these values? So we want to get the values now. Is that okay? All right. So now, so we look at curve fitting first. Curve fitting is a statistical technique used to find the best fitting mathematical function that describes the relationship between a set of inputs, which I've explained the other time, and outputs. In R, curve fittings can be performed using functions like LM, NLS, and other packages. LM actually is used for fitting linear models. NLS for fitting nonlinear models. Is that okay? Are we together? All right, so we'll be doing something now. So, for instance, we want to fit some straight line to data. I sent some data, like I said, to the platform. I believe should have downloaded it by now. Okay. I'm going to be doing two things at a go. Now, reason I sent those data sets is because I want you to be able to import your data. For some of us, we have been using inbuilt data from R since, but no, in reality, you have your data collected and stored somewhere else, right? So you have to bring it into R first. So, and then that's the first thing that we'll do. Now, we all know that the equation of a straight line is given by this, y equals to a plus bx, isn't it? Are we together? Now, determining if this is the kind of function we should use or not is dependent on our data first. Let's first see the data. Are we together? Are we together? All right. Now, in this place, I have saved my own data in the parts, in these parts. Is that okay? Now, there are two ways you can bring in your data into R. It's either that you put the data in your working directory, or at all time you want to use data, if in case you don't want to stress yourself, bringing all the, going to look, saving the data in the work directory, you can as well trace the path of the data, where the data is. And R will go there to go and locate the data there and will bring it. So that's exactly what I've done here. I didn't want to put it in a certain working directory. I just want R to go and find it wherever I put it. So I put the directory. So in this case, you just put, so I'm storing this with data, right? You already know how to declare variable, isn't it? With data, and then read underscore CSV. For some of you, to be read.csv. Check the WhatsApp group, it's there now. Eh? It has been what? Deleted? I don't get. It's there now. Please check your connection. If somebody said it's there, then it cannot be there for you. It cannot now delete itself. So just check. Maybe your connection. You can check your connection and be sure. All right. So I will be working with both R. I'll be interfacing it. But the same code I want to type in R is what I've typed here. Now, somebody will be smart here, because I'm sure you don't want to write my own parts. If you write my parts, R will look for it. He will be tired. He will tell you I cannot find it and throw error at you, right? Yes. Because it's my own parts. So you will have to declare your own parts. Is that okay? Where you put the data. Do you understand? If you have downloaded the data and maybe it's under download, then you should put it. Okay? So you have to, and I think I've taught you how to get the directory, the path, isn't it? Okay, let me do it once more. Let's say this is my path on the desktop here. What do? I just come here and then click on this place. Look at it, everybody. Click on this place. Once I do that, do you see that it's bringing the paths? Is that okay? So you copy the paths. Now, copy the paths and then put it. So put it here where you have C. You see inverted comma, right? C full colon users. So you put that part there. But you see that it's not including the data, the name of the way you save the data, right? So I have to include it, which is this part where you're having data for linear equation dot CSV. So you put that also. And don't forget, you change the backward slash to what? Forward slash, or you use double. Is that okay? All right, so do that now. This other part is because I think I should have even deleted it. Sorry for that. Okay, so you type that. Don't forget that I loaded library read R. So you to do that. Are you there? Don't forget it's your own part that you have to trace, not my own part. And I've just shown you how to do that. Go to where you saved that data. Right? On the taskbar up there, click on it. And then it will display the part. Copy that part. Let me do it again. Right? So just come here where I put the data. Copy the parts. Right? When you copy the parts, that's why, see, when I'm teaching, when I say see something, look up and see it now. If I have done it and you are not looking at it, you still ask me that question again, and we'll stay long on it. And I'm just giving 40 minutes to do a very long something. So, I think you would want to just look at, when I say look at it, just look at it. don't be too busy to look at something when I say you should look at it. All right, so now let me go over it again. Okay, so I've said, let's say you saved it in download, or you saved it in document, wherever. Me, I saved my own in where? Desktop, right? I just open the folder where it is saved. Is that okay? Open the folder where it is saved. Go to the menu bar here. Look at it. Just look up and see. See the menu bar. Where I have what? What are you seeing there? New folder, right? Just click on it. Once you click on it, what is it doing for you? It's so copy it. Is that okay? Copy that part. And when you copy it, right? So that's the part you are seeing here. So that's the part you copy and put in this place. Is that okay? Copy it, right? And put there like this. And then add to it the name of the data that you want. Because in that part there are many data sets, right? The name of the data are saved. If you use capital D to save it and you call for a small d, R will tell you, I cannot find it. So please ensure that everything is done correctly. All right. So have you been able to load that? Who has successfully done that? I love that. There are sharpshooters here. Okay, so run it. Just run that. What is the issue? It's been sent. I'm not in control of the thing now. It's there. It's there. Waiting for a message. Somebody can help us with the send. It should not be me again. I'm already here. All right. So I said you should add the what you use to save the data, right? .csv, don't forget, because what I sent to you is CS, they are CSV files. So when you do that, then view the data. Are we there? We have not really gotten to the work. Oh. We are still doing preliminary, so please let's be fast. So you can view the data. I sent 3 documents. Yes, I know. Well, I didn't say I sent parameter estimation. I said I sent data. And you have seen the data. Download the data. That's what I need. Are we good? How many of us have been able to load it? Let me see those of us that have been able to load it. Good. Good. Great. We are moving. Yes, yes. So view your data now. It's a very small data. What data am I using for now? Data for what? Are we together? I'm using data for linear equation, so you can view it now. Did you see your data coming up? Good. So we are making progress. All right, now I want to plot the data now. Just to visualize, right? So you know how to plot now. So the data, right? You know when we use dollar sign, what am I trying to do? I'm trying to specify the colon, isn't it? So data, then colon, X. I want to plot it against what? The colon Y, isn't it? And the type is L, which means line. L is not 1, no, it's L. By now you should have known that type there means what? Line. Then line width is 2 and color red. Then X lab Y and Y lab, sorry, Y. All right. Are you there? Can you see that? To run it, you should see this kind of plot. You should see this kind of plots. Do you have that kind of plot? How many of you got this kind of plot? Okay, you are still typing. Let me wait for like 30 seconds for you to do that. Are we there? Good. Do you have the plots? Can you give me high five if you have the plots? All right, high five. Do you have it? So high five. Do you have it? What's happening? Who is the representative here? Good, have it. There's no network issue about this one though. So get no problem. If you are still trying to get the file, maybe just join those ones that have already gotten the file and be looking at it so that you not miss out. Because the flight is already taken up. You got the plot already? Great. So the idea now is that I have these plots. For now, let's say I have not even thought about the model that I want to use. All I see is that, I see these plots. And I look at it that, is it possible that a linear graph can at least capture some of the points? So looking at this, I can start with linear graph, isn't it? To even see how closely it's able to pick the points. Are we together? It's not entirely linear, but to some extent, some linear graph can start it. Can start with this. Is that okay? So now, in the LM package, which I told you that helps to fit linear model, I don't need to specify my model again. The model that is used to build it is that linear model. Y equals what? A plus bx. So once you specify that you are using linear model, that function is in there already. Is that okay? You don't have to specify the function again. All you need to specify for it is what's on your x-axis and what's on your y-axis. Is that okay? And afterwards, it will just help you to fit. So can I move away from this place now? All right. So now model underscore LM. You see what did I put now? The y-axis, right? Are we together? Tilde x-axis. Are we together? Is that okay? So when you want to fit linear model, you don't need to specify the model, write the model again, like we were trying to do yesterday. You don't need to write it because it's already there in the LM. Are we together? You just need to specify your y-axis and specify your x-axis. It's automatically packaged. But other ones will be doing that. We have to be the one to type our equations there. So once you do this, you can access your models. For instance, you can access your model by just typing this, check fitted values. For you to even know what you can check, once you type model underscore LM and put $, it will give you a list of things that you can check. Now do that and then let me see if you actually got what I've said or not. All right. Model underscore LM. Then you are assigning that to what? LM. And you are specifying your y-axis tilde what? The x-axis. Are you there? You saying no. If it is that you have not downloaded data, don't say no. If it's that you are not getting the code, then if you say no, somebody can come and help you. The first code. Can somebody who has gotten the first code send it to the platform so that you can enjoy it? I think I saw yesterday that some of you were snapping and you were sending it to the platform. I think it will be good like that so that we don't have to be staying on the previous one for too long when somebody has already moved to the next one. So somebody can do that, send to the platform, and then those ones that are on the previous line can enjoy that one. So let's help each other like that so that we will not be delayed. Are you there? So you can also check the summary of your data. Yes, the summary of your data. Okay. This, you know that when you put hash, it will be seen as comments, right? So I want to use this code. It's line of code, not comments. So I have to remove that hash. Model underscore LM, then dollar sign. I said, well, immediately you put the dollar sign, you see various things. So you can check your fitted values. Fitted values are going to be the what the model is saying, right? The values that the model is producing, right? Okay. So you can also check the summary of your data, of your model. And when you do that, you can plot now. So let's plot the model against data. So the first year plot here is, we are plotting the data first, right? We are plotting the data. The first one here, we are plotting the data that you have plotted before. I just want to join the model with it. Is that okay? So you are plotting the x on the x-axis and y on the y-axis. And main, just main will give you the title. Right? Main, you linear fit. Then point character, 19. Now, what I mean is that I want this data to be plotted in terms of points, right? And I have to specify point character 9. There are different point characters, which as you study along, you get to know. Because that's not what I'm supposed to teach now. So you get to know, right? I have known that I want to use point character 19. Is that okay? And then I'll label my x-axis and y-axis. And now, don't forget yesterday, we taught this thing yesterday, that if you want to see two graphs on the same, if you want to see them together, when you use plot for the first one, what will you use for the second one? Lines. So that's the one, is so that we can compare model and data together. So lines. Again, lines, I am bringing in the model fitted values because I want to compare it. And I am saying the color should be what? Blue, right? And the line width should be what? 2, right? If I don't specify type, it will by default give me continuous line. Is that okay? All right. Then legend. I taught you how to put legend yesterday also. So put the legend there so that we can see what we can be able to distinguish which plots correspond to what. The one that is for data and the one that is for model. All right. Let me allow you to type that. Are you almost there? Are you enjoying yourself? Like a physiotherapist. Does it feel good? Do you feel good? All right, ICAMMDA team, your help. People need your help. I'm asked to request for your help. So they said you should come and help them. I believe you want to provide the help. So please, can we come and help people? Thank you. So ICAMMDA team, please come and help people. Thank you. All interns seated, please, can you come and help people? Okay. So please, are you done? By now, a lot of things should be getting clearer in terms of where to put comma, in terms of where to put inverted commas, in terms of where to put to close your brackets and all of that. Yes, ma. I'm with you, ma. Okay. Ah. Are you there? Ah, sorry. You should put it there. Yes, one of the quotes is missing, and I love this observation. That's a beautiful one. He's learning very fast. On the data, one of the quotes is missing, right? So you should put it. Okay, so how many people have been able to get their results? Wow, great, 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 great. I love this. So you got something like this. Beautiful. People are already getting it. So if you are not getting it, stay on it to get it. I will not leave you until I get you. Let that be your mission. A resolute mind. All right? Oh, I am blocking you. Sorry. So, Alpha. We still have a long way to go. This is one very tiny thing out of everything that we must do. Let's be very fast. It's just a very tiny thing. Now, let me also ask you something here. When you put your model underscore LM dollar, what are the various things that came out? Can you tell me? Fitted value. What again? No, now. When you put model underscore LM dollar without putting in anything yet, something should. So what are those things? Tell me. I want to hear them. Coefficients, residuals. Good. So now, if you want to know your model explicitly, then you can just put model underscore LM what? Coefficients. Because the coefficients that are estimated will now come out. Is that okay? So that you can write your model. In case you want to write your model, don't forget our model is y equals to what? Can I clean this place? This thing? Can I clean this thing? Okay. Don't forget the model fitted was y equals to ax plus b, right? The coefficients there are the what? Can we be together, please? The coefficient there are what? A and what? B. So just get your, in order to know what A and B are, so type model underscore LM, right? Dollar sign what? Coefficients. And then you get your value of A. Do you have it? So that means explicitly your Y. So what's your A? That's the first one. 0.307 plus, sorry, that's BX, right? Plus the second one. 3.13x. So meaning this is now your explicit equation, right? Do you understand that? Do you understand that? I said this is now your explicit equation. So the other time when you were asking Mr. Sam that, how did you discover, did you determine your values, right? So you see now, for linear model, we have determined the values. By checking on your model, the coefficients. Check now, check coefficient. What do you have there? Did you run it? Did you observe the values given to you? What do you have? You said you didn't get 0. What did you get? You didn't get anything. Somebody, maybe you didn't type the correct thing. Are we together? My time is really going very fast. I have not done deterministic model. So we really have to, if I just thought, let me show you how to do model core fitting first. So maybe I will have to jump other ones so that at least you can have a taste of the deterministic model too. Sir, how do I do what? I said just do model underscore LM. Once you put $sign, all the outputs that that model provides for you will be listed. Did you do that? Check it. It will be listed. One of the outputs is coefficients. All right, thank you. Are we good? No, you have not typed it. You are saying no. It's like no is a default answer. You are typing, you have not finished typing. I'm asking if you are good. You said no. Are you envisaging not to be good? Eh? All right. So how many of us got the plot already? Let me see. Let me just take statistics. You got the fitting process very well. Good. Oh, I can see whenever Prof smiles at me, my mind calms down. All right. Did we get it? Hey, one person on this row. It shouldn't be. Did you get the plot? Now wave it and wave the hand very well. Encourage somebody. Okay, just two people here. A lot of people are still struggling with it. Is it that you're having error or you are still typing? Can I get a filler from you? Are you having error or you are still typing? Oh. Eh. All right, sorry about that. You will run it afterwards. Just maybe you sit down by somebody who already has those things so that you don't miss out entirely. Okay, can we move on now? Can we move on now? Yes or no? Yes. I have told you, if it's about typing, snap it and be typing by your side. Don't keep us because you are typing. You know, if you have to keep us because you are typing, then others will not benefit from other things. So you can just snap and be typing. Eh? Sir? If you are still typing, can I see your hand? You are still typing, let me see your hand. Okay. All right. You are done typing and you got the result. Let me see your hand. Sorry, I want to know what the chance you make. Okay, good. You are done typing and you have error. Let me see your hand. You are done typing and it's error that you have. You have error. Please come and help people that have error in this place. You are done typing and you have error, please. Now, the reason you should raise your hand is because you are typing and you have error. If it's that you are still typing, please, like I told you, just snap it and then type it by the side so that we can move on. All right, thank you. So you should have this plot, and I think I got a response that we got such. Now, but we also know that not all models are linear, right? Not all models are linear. So let's quickly see how to work with nonlinear models, right? So please, again, you read in your data just like we did before. You read in your data, and like I said, I don't want this guy to be part of it. I did that for my because I needed it, but you don't need it. All right. So bring in your data first. Please, everybody, let's bring in our data. Data underscore NLS. This time around, you already know the process for bringing in the data, right? So you can just save it as data underscore NLS. Okay. Bring in your data. Okay. Now, I have saved also my colon y as y and colon x as x. Is that okay? Because I need it. Are we together? Now, you would also want to do something that I didn't do here, but you should do it. Can you plot your data to view it? Plot your data, x on the x-axis and y on the y-axis to view it, how it looks like. How the data looks like, to view how the data looks like. I didn't do that. Somebody is already asking me to stop. Sorry, I think that, let me just finish up this one and then we stop at this point. But we know that as far as nonlinear, core fitting is concerned, can ensure that we have learned it. Are we together? Are we together? All right. Now, did you plot the model? The data. Okay. How does it look like? Curve, right? And if you look at that curve, you can imagine that this is a growth, isn't it? Is it not growing? Like an exponential growth, isn't it? Are we together? Like an exponential growth, right? So, the reason for choosing an exponential model is because of the data that we have. That's why when I defined functional models, I said the goal of the functional model is to find that function, right, that defines the relationship between the input and the output variable based on the observed pattern in data. So the observed pattern in data this time around is like a growth, it's giving us kind of growth. So it's like this, going like that. So we should be able to use that. And you know that generally, exponential model, for instance, if you look at this, can be expressed as y equals to a exponential bx, isn't it? Where a and b can be anything, either positive or negative. All right. Now, look at this. So, unlike the other time, please let's pay attention. Unlike the other time, where I said the linear model, the LM, inside of it is already built. Please let's be together. Inside of it is already built the model, right? This one is non-linear model, and there are many of them that you will be the one to determine. So now we have decided to use the model A exponential bx, isn't it? Are we together? So I will now have to specify also what I want my output variable to look like, which is y. So I want y to be equal to what? Are we together? To be fitted to what? A times exponential bx. So if it's another model that I want, I will still be the one to specify that. Are we together? Are we together? Yes, so the model is specified already here. A times exponential bx. That other one, linear model, I don't have to specify it. It's inbuilt already. Linear, non-linear models, there are many of them, right? They don't follow the same structure. They are different. So you have to specify it, the model that you want to use. So I've specified this. And now this starts. Now what are the variables in this model? Can you tell me what the variables are? What are the variables? Is a variable there? What are the variables here? X and y. What are the coefficients there? All the parameters in, if you want to look. A and b. Those are the things that I want to estimate. Are we together? A and b is what we want to estimate. But for in the non-linear model using NLS, you must specify an initial guess. State an initial guess. Maybe whenever I come back, I'll be talking about how you can think of various initial guess, because that one is another try and error thing. Is that okay? But for now, just take that I've specified my initial guess. A as what? 3 and B as what? 0.1. So it should start from there. That is, it should start optimizing the model from there. Are we together? So for time's sake, I won't go through that. Like I said, it's a matter of try and error. Is that okay? So when you put it like that and you run this code, so you can run the code. When you run the code, it has now done the parameter estimation. And you can check the summary if you want to check as summary model underscore NLS. How many of us have tried that? Did you run the model already? Good. I hope you didn't have error. Good. So model underscore NLS. Then, so now plot it. Let's plot the outcome. We can plot the outcome. I've told you can snap so that we won't have to wait for long. So plot it. And when you plot it, you should have something like this. Where the red is what? Model and black is the data. Don't worry, I'll go back to the code, but this is what you should have. Now, when you finish, you can also check model underscore NLS and put dollar and see the different kinds of things that are produced. What do you have produced? What are the various things that you can check? Model underscore NLS. What do you have there? For those of you who have gotten the model underscore NLS, you've run it. You have what? M. Okay. Data. Yes. Bring it, let me see what you are talking about. All right, so we have to stop at this point. Now, again, don't forget that the model we used was y equals to what? A exponential what? Bx, right? You can know what A and B are by just running model underscore NLS. Just run this, Control Enter, and then you will see from there A and B. What do you have as your A value? What's your A? You have A as 3, right? What's your B? 0.1x. So this is your explicit model equation. All right, thank you. Till next time, we'll see.